Hi guys, welcome back. So today we're solving a problem on curvature of a vector function. Okay, so here we are asked to find the curvature of an elliptical helix that is described by this given vector function, which is a cosine t, b sine t, and ct, where a, b, and c are all positive. Okay, so to find the curvature of the vector function, this is the formula. And here this letter is the Greek letter, which is read as kappa. Okay, so to find for kappa, this is the formula that if you're given a unit tangent vector, so you can take the derivative of the unit tangent vector and find the magnitude of it and then divide it by the derivative of the vector function and magnitude of it, okay? Or another way to find it is when you're not given the unit tangent vector, which is to find the first derivative of the vector function and then cross product it with the second derivative of this vector function and then magnituding it, and then finally dividing this by the derivative of the vector function and magnituding it and find the magnitude of it and then cube root it. Okay, now let's continue with this problem. So, and by the way, if you want to use this formula, you can use it only when you have the tangent vector given. But here, since we do not have the tangent vector given here, so we're going to be using this formula, okay? And if you want to know how to calculate the unit tangent vector, I've made a video on that. I will provide the link in the description below, so you can check that out. Okay, so let's continue. So, we are solving for kappa using this equation, okay? So here, what is the first step? The first step here is to find the derivative of the vector function. Okay, so let's find the derivative of the vector function. Okay, so calculating the derivative of this, here, just remember this sine t equals to cosine t, and cosine t equals to negative sine t, okay? This is just like a reminder to calculate the derivative, okay? The derivative of sine t is cosine t and derivative of cosine t is negative sine t. Alright, so here we have a cosine t. So a is a constant, so it just stays there, and the derivative of cosine t, as we see in there, it's negative sine t, right? So we put negative sine t. I had, and then moving on to the next one, which is b sine t. So the derivative of b is b because it's a constant, and then sine t, the derivative of sine t is cosine t j hat, and plus ct, and the derivative of ct will be simply c because c is a constant, okay? So here we have the first derivative now. Now what is the next step? The next step is to calculate for the second derivative. Okay, and for that we'll have to derive this once again. Okay, so taking the double derivative of the vector function, the original vector function, or simply taking the first derivative of this vector function, okay? Okay, so we're deriving this vector function now once again. So here negative a is just negative here. A, it's a constant, but the derivative of sine t is cosine t, and plus b, what's the derivative of cosine t? It's negative sine t, right? You see here, negative sine t. So we're gonna have to put a negative here, negative sine t j hat. And what's the derivative of a constant? It's simply 0. So we don't write it, or you can just write 0 k hat, okay, if you want. Okay, let's move on. So what's the next step now? So now it's we'll have to cross product this, the derivative of the first one times the derivative of the second one. So taking the cross product, so as you know from the linear algebra course, that how do we take the cross product of it? So we do like this, I, j, k, okay, and then here we have the first derivative, so we write here the components of the first derivative, so negative sine t, b cosine t, and c. So you see here I had, because this was I hat, and b cosine t, this belongs to j hat, and this was for k hat. I forgot to write a k hat here. Okay, now we have to cross product it with the double derivative, so we're going to write the components of the second derivative underneath. Okay, so here negative a cosine t, negative b sine t, and then 0. Okay, so how do we calculate for the cross product? So we cross the first row, so we cross the first column. Okay, so we cross the first column and the first row, and what are we left with? We're gonna multiply this. So, okay, so we're gonna multiply in like cross multiplication. So then this multiplied by this, and then negative this multiplied by this. Okay, so if you do this multiply by this, this gives 0, and then if you do this times this, this is going to be negative bc sine t, right? Okay, so let me just write it. So this will give us negative bc sine t I hat. Okay, because we crossed out the first row, that's why we put I hat. Okay, and remember this is plus, minus, and plus. Okay, so the next one, it's going to be negative because it's negative here in here. Okay, so let's move on. So here we're gonna cross out the jth row and the jth column, so like the second column and the first row. So crossing that out, we're gonna multiply this times this, so like in cross product, this times this, and then negative this times this. Okay, so if you do negative a sine t times 0, this will be just 0, and then this times this will be ac cosine t, and yeah, when you multiply this times this, you have to put a negative, so this negative will cancel out this negative, making it a positive here. And yeah, I forgot, sorry, this has to be positive as well because it would cancel out when you were multiplying these two, right? So it would cancel out the minus, so it would be plus in here as well. Sorry for that. Okay, so let's move on. So what are we going to write then? Okay, so let me just remove all this mess here. And then what did we say? It's gonna end up being AC cosine t. Okay? Alright, so let's move on. What we were writing? Okay, so then we have to cross out the third column and the third row, and we're gonna multiply this negative times this. Okay, so this times this, so you see the negative cancels out, so we're gonna have plus AB, and yeah, I forgot the G hat here, sorry, and then AB, and then you do sine squared of t, and then you put a negative when you go up, right? So you're multiplying this times this, so you put a negative, but this negative cancels out with this negative, making it a positive again. Okay, so positive AB cosine squared of t, because there are two, right? When you're multiplying cosine squared times cosine squared, so it becomes when you're multiplying cosine t times cosine t, so it becomes cosine squared. Okay, so it's the same case with sine t, so that's why it's sine squared of t. Okay, and then this times k hat, because we crossed out the kth row. Alright, so what is the next step? So the next step here, you can use a trig identity to simplify it, right? So the trig identity that we are using here is going to be sine squared of t plus cosine squared of t is equals to 1. Okay, so this is the trig identity that you're using here. So if you factor out the AB here, okay, so I just do that. AC cosine t j hat plus AB, factoring the AB gives us sine squared of t plus cosine squared of t k hat. Okay, so I just factored out the AB and I'm left with this, right? And this looks like this, right? So you can replace it with 1. Okay, so using this trig identity in here gives us 1. Okay, so then we're gonna be writing BC sine TI hat plus AC cosine TG hat plus ABK hat. And this is actually our cross product that we wanted to calculate for, right? So this that we were looking for. Okay. So now when we have the cross product, what was the next step? Okay, so as you guys can see from the formula, after finding the cross product, we have to take the magnitude of it. Okay, so taking the magnitude, how do we take it? We square each component and then square root the whole thing. So squaring each component, why did I put an I hat? Sorry. Okay, so squaring each component plus AB squared, sorry, no J hat, and then square rooting the whole thing. This will give us, so negative cancels out because of the square root, so I don't need to put in here, BC sine squared of T and B squared C squared, of course. Okay, and then plus A squared C squared cosine T squared plus A squared B squared. Okay, alright, so what is, and then square rooting the whole thing. Okay, so this is going to be the answer to here. So this is what it's gonna go in here at the top. Okay, so the next step here is to find the derivative of it, the first one, so which we already have it. Okay, and then it's to find the magnitude of it. So let's find the magnitude of it. Okay, so we already have the first derivative. We're finding for the magnitude, and how do we do that? We square each component. So okay, B squared cosine squared plus C squared, and then we square root the whole thing. So this is what we get if we take the magnitude of it. Okay, the first derivative. Okay, so the last step is just to divide these two things. And then okay, so let me write it in here. So here kappa, kappa is equals to, so this what we have here, this goes at the top, B squared C squared sine squared of T plus A squared C squared cosine T plus A squared B squared divided by what we had. This is the answer, but we're not done yet, right? We're almost there, but we're not done yet. You forgot the square root of, there is, if you see carefully here, there was a cube as well, right? So we need to put this to the power of 3. So this is the answer, but simplify this a little bit. So for example, the square root of A is same as A to the power of half, right? So if you have square root of A and then you have a cube and then you have a bit to the power of 3, then you can simplify it here, because you know this is same as half to the power of 3, so you can just write A to the power of 3 over 2. Okay, so here you can write it the same way. So here you can simply remove this square and this and just make it to the power of 3 over 2. Okay, so this is going to be the final answer, And thanks for watching. That was it for today's video. Bye.